You just wait for 2-3 minutes, then we'll start. Okay. Meanwhile, you can note down the table. Question also. The following reaction. The following reaction was investigated as indicated in the following table. The following reaction was investigated as indicated in the following table. Determine the order, determine the order with respect to each reactant determine the order with respect to each reactant and the rate law for this reaction and the rate law for this reaction. I am repeating again the question. The following reaction was investigated as indicated in the following table. So note down the table and determine the order with respect to each reactant and the rate law for this reaction. The reaction given as 2NO2 plus F2 gives rise to NO2F. So read clearly the problem, understand and try to attempt it. I am here to solve the problem, but I want you people to read and nothing will happen. ఏం చేయాలి మన పని మనం చేసుకుంటే తన పని చేసుకుంటాం. He has given one reaction here, 2NO2 plus F2 gives rise to NO2F. And what for that reaction, he has given some table. The table indicates left side is the first column represents the experiment number. That means the one who formulated the problem has done some experiments. So there are 3 experiments, 1, 2, 3. And in each experiment, he has given some tabular form, like NO2 in the bracket capital M. That means concentration in terms of moles or molarity, whatever it may be. The concentration he is given. So NO2 concentration in each experiment he has tabulated in the second column, and similarly the concentration of F2 again in the concentration units of M he has tabulated in the third column, and the last column represents the initial rate, because every reaction has the rate. We already defined what is rate, what is molecularity, what is order of reaction, everything we understood. Is it clearer now? So we come to know all those things. Now you don't say that we don't know the reaction rate. Reaction rate is rate at which the speed. We defined already the reaction rates. The disappearance or the formation. Fine. Per unit volume, per unit time, or depending on the reaction type, whether it is volume or a surface area or sometimes weight. Fine. So accordingly we define the reaction rate. Now in the last column he has given the rate, maybe in some units, m per second. So for every experiment he has the data of concentration of NO2 and F2 and the rates. Now he has asked this question, what is the order of the reaction and what is the rate expression? How we proceed? First understand the problem. So he is asking the order of the reaction. What is order of the reaction? We defined the powers to which concentrations are raised. We know that the powers to which the whenever any concentration is raised to the power, that power is called the order. So that is don't know. That means n is not known. And what again is asking? Rate expression. That means what is the rate expression initially for nth order reaction? For example, A gives rise B. We usually write minus RA. Why minus RA? Because always the rate should be written in terms of the reactant concentration. Because reactant we have a convention of keeping the minus sign because it will be always will be depleted, lost. So that's why we'll keep minus sign. So minus RA is equal to K into constant because K is the temperature dependent term, C is the concentration dependent term. So we write K into Ca. We write power as n because we don't know the order of the reaction. Is it what we follow? Now similar terminology, you assume the reaction rate here. Can you write reaction rate for this reaction? How we will write? What is the reaction rate for this reaction? Minus
R and O2 is equal to
R and O2 K into
C and O2, right?
concentration of NO2 into concentration of how many agree to keep power 2 here, power 1 here? Have I mentioned this reaction rate is elementary? Keep in the mind, for elementary reactions only we need to have the stoichiometric coefficient balanced with the corresponds to the rate expression. Here he has not mentioned the reaction rate to be the elementary reaction. Has he mentioned it's an elementary reaction? So why you should keep here 2 and 1? If it is an elementary reaction, absolutely correct. Keep the stoichiometric coefficient here and keep the stoichiometric coefficient here. But he has not mentioned. Is it not? So we don't know. We don't know it's an nth order. That's what I told you. So minus RA is equal to K into Ca power n. So similarly, concentration powers of n, we don't know n. Is it okay? So you should not keep here power 2 and power 1. Because order is not known. That's what he asked the question. Again, you are keeping order as 2 here. You are doing blunder mistake. Is it? The first question asked is what is the order of the reaction? If you know here 2 and 1, the order of the reaction is already known. You are directly keeping no. You cannot because he has not mentioned it is to be an elementary reaction. If it is elementary reaction, absolutely correct. He has not mentioned elementary. So we don't know the order. So keep it as n. Now he has given some tabular. Now how we will solve? See, let us say for the first reaction, first experiment, let us say this is R1. Maybe this one is R1 because the first reaction, let us say. Okay, maybe this one is concentration of component 1. Maybe this is concentration of component 2. Maybe I can say Ca1, maybe Cb1, maybe because of the first reaction. Similarly, if I write this as reaction rate 2, this may be same Ca of second experiment and same Cb of second experiment. So can I write now? Because if I write rates R1 is equal to sometimes K into okay concentration. So maybe here what is concentration NO2? So NO2 one concentration, other concentration F2 power X because power n. Is it not? This is whole power n. Fine. So for the first reaction I will keep this concentration value. For first reaction I will keep this value. For the second reaction, maybe the second experiment, the constant will be constant only, it will not change. Whatever the values here, same n I don't know. Here I will keep concentration of N2 for the second one, this value. Concentration of F2 as this value. Now if I divide, because I know R1 value, I know R2 value, I know these two values, can I get n value?
Yes.
Do it then. Understood? Rate as concentrations power n. Because two components are there, so two components, two concentrations. So for the first experiment, I took these are the first values, and this is the first rate. First rate, first concentrations. And for the second one, second experiment, I took this as the second rate and second concentrations. So substitute these values here and divide it. You know R1 value, you know R2 value. Maybe in terms of minus, minus should also be cancelled. Now what is the n value? Or can I keep it? Maybe R1 0.855 by 1.71 is equal to K is already cancelled into concentration of first one 0.15 into 0.15 by 530 into 0.15. Can I write 4 power n because n is common? So this is cancelled. Now what is left is 0.15 by 0.12, 0.30, that means 1 by 2. Is it not? 1 by 2 power n is equal to 1 by 2. So what is n? What I did here, again I am explaining. What I did here, he has given some values, he has given some reaction. I written the rate expression. How I written the rate expression? I always write the general rate expression. If one component is there, K CA power n. If two components are there, K CB CA power n, CB power n. Or if concentration of B and B are different, I write N1, N2, etc. Because he has mentioned it's an overall order, so keep it as n. And write for the two experimental values, you tabulate it, divide it, you will get n value. Now once you know the order of the reaction, that is n you know, then you can write the rate expression. How we will write? See what you want for the rate expression. This is what our rate expression, no? This is what our rate expression. Fine. So n is known, but K is not known. The rate expression, K should be known. Is it okay or not? But how do I know K? Very simple. See, for the first reaction, you know R1, you know CA1, you know CB1. Can you keep here? CA1 you know, CB1 you know, N you know, R you know. Can you keep to get K?
Yes.
So what is the K value? For the experiment number 1, you know R1, you know concentrations. You know N, just now recently we got obtained N. So keep N, substitute.
6.6.
You get?
6.6.
And any other answer? No. Correct. That is the correct answer. So K you obtained as 38. So what is the rate expression? Rate expression R, maybe in terms of if I write for minus, maybe for N1 if I write, K is 38 into concentration of NO2 power 1 and concentration of F2 power 1, because N I got 1. So no need to write 1. So this is what my rate expression. what I did, I took the rate value, I took the concentration value. In general, what the expression I written, and just used the first two rows only, substituted. And now, if you are very clever, you know how to do all these things. If you just understood what is the concepts I have given in the previous class, without attempting also you can say the answer. How? I clearly explained what is zero order reaction, I clearly explained what is first order reaction, I clearly explained what is second order reaction. Zero order reaction is one which is the reaction rate is independent of the concentration. First order reaction is one which is proportional. That means if I increase the concentration by 1, rate will also increase by 1. If I double it, it will be double. If I triple it, it will be triple. For second order reaction, power 2. That means if I double it, it will be 4 times. If I triple it, it will be 9 times. Just look at the concentration. If it is doubled, rate is doubled. Just like check the values. Concentration is doubled, rate is doubled. Just multiply with 2, you will get this. Multiply with 2, you will get this. That means I am doubling, rate is doubling. I am tripling, rate is tripling. First order reaction. No need to calculate n equal to 1 like this. Very simple. And once you know n equal to 1, you substitute here, you will get the k value. Very simple. Understood? Clear? So I given the shortcut, I given the elaboration. Both ways I explain the problem. Initially, people should understand what is the rate expression, use the two values. But once you are familiar with the concept, just seeing the values, you can guess what is the reaction rate. So in GATE, this much of data will be given. Maybe 3 here given, I will maybe 10 will be given. And ask it to find R. Can you do all these manipulations? Just use your brain. What is first order? What is second order? What is zero order? Simply within fraction of seconds you can tell the answer. Yes, it is the first order. Because as I am looking, the concentration is doubling, the rate is doubling. Maybe you can see here concentration of B doubling. You see, any of the concentration of the reactant is doubled, the reaction rate doubles. First order. Note another problem. A reaction with only one reactant A was investigated as indicated in the following table. The reaction with only one reactant A was investigated as indicated in the following table. Determine the order with respect to A. Determine the order with respect to A and the rate law for this reaction. A reaction with only one reactant A was investigated as indicated in the following table. Determine the order with respect to A and the rate law for this reaction. Similar question I asked. Attempt and tell. I asked for n, I asked for the rate law, that means the rate expression. Do it and tell me the answers. Can we say it is first order?
No, sir.
Second one.
Second order.
As concentration increases. Concentration is independent of, rate is independent of concentration. Zero order.
Concentration is independent of reaction rate. It is very clear, na? Why you don't understand? I don't know. You look at the concentration value. If it is doubling, what is the reaction rate?
Reaction rate should not double. It is 4 times. Second order.
Second order reaction, amma. When the concentration is doubling, reaction rate is 4 times. You multiply with 4, you will get the second one. Direct one. Why you have so much of probabilities in the mind? Multiply with 4, are you not getting the second reaction rate? What you will get after multiplying with 4 here? 1.2 10 power minus 4. Is it fine? So that means what? When reaction rates are becoming 4 times, concentration is just doubling. Is it not a second order? Just now I told. Without looking, without manipulating, you can say the reaction rate. Now you find the K. So N equal to 2. So what is K? So how will you write the rate expression? Minus R is equal to K into CA power N. N is 2 now. Okay? Now you know CA value, you know R value, you know N value. Substitute to get K value. Take first reading. Take first reading. First experiment value CA as 5 to R as 3 to 10 to minus 5.
755 10 power minus.
How much?
755 10 power minus.
That's all. Correct. So minus RA is equal to 7.5 into 10 power minus 4 into CA square. That's all. So second order rate constant value. Any issue? Still? ఇంకా మైండ్లో ఏమైనా గులకరాలు ఉన్నాయా? తీయండి, రాళ్ళు తీయండి. క్లియర్గా చెప్తున్నాను. ఫస్ట్ ఆర్డర్ అంటే ఏంటి, సెకండ్ ఆర్డర్ అంటే ఏంటి చూడగానే చెప్పొచ్చని ఫస్ట్ ప్రాబ్లం చెప్పాను. మళ్ళీ సెకండ్ ప్రాబ్లం వచ్చేసరికి మళ్ళీ అదే డౌట్. జీరో ఆర్డర్ అంటున్నారు, ఫస్ట్ ఆర్డర్ అంటున్నారు. చూడండి ఎట్లా రేట్ వేరీ అవుతుంది. కాన్సన్ట్రేషన్ డబుల్ చేస్తే రేట్ ఎలా వేరీ అవుతుంది. కాన్సన్ట్రేషన్ డబుల్ చేసినా రేట్ మార్చలేదు. సేమ్ రేట్ ఉందనుకోండి, అంటే సేమ్ రేట్ పెర్ఫార్మెన్స్ ఇక్కడ ఉందనుకోండి, జీరో ఆర్డర్ కరెక్ట్. When I am changing the concentration, but the rate is same, independent of concentration, zero order. కానీ ఇక్కడ నాకు ఆ వాల్యూ లేదు కదా. ఇక్కడ మీరు వాల్యూ అప్లై చేస్తే 4 టైమ్స్ మల్టిప్లై చేస్తే వచ్చే వాల్యూ ఉంది. అంటే కాన్సన్ట్రేషన్ 2 టైమ్స్ ఇస్తే రియాక్షన్ రేట్ 4 టైమ్స్ జంప్ అయింది. అంటే పవర్ 2 ఉంటేనే అలా జంప్ అవుతుంది. సెకండ్ ఆర్డర్. ఓకే, నో డౌట్. యూజ్ ద డేటా. Use the data in the table below to determine the rate expression for the following reaction. Use the data in the table below to determine the rate expression for the following reaction. the reaction given as 3 argon SO2H, hydrated form of argon sulfur dioxide, gives rise Ar SO2 Ar plus Ar SO3H plus H2O. Yes. Have you said second order? No, wait. Let her answer. How you say the second order? What makes you to choose as second order from the table? Huh? You calculated? You calculated? And very quick you calculated the rate order. So any resemblance? Just seeing the table data values, can you say it's a first order or second order, zero order? Any doubling here? Doubling the concentration, doubling, or doubling becomes 4 times? Any resemblance here? So nothing is there. So you have to go by traditional way. First method. Write minus R is equal KCA power n and do the two set values. R1 is equal to R2 is equal to divide it, get n. Because from our eye, I am not observing anything here. Doubling 4 times or doubling, I am not observing anything. So do by traditional way. So minus RA, maybe A here is AR SO2H. So K times Ca power n. So take R1 value this one, R2 value this one, Ca1 value this one, Ca2 value this one, divide it, get n. సో క్యాలిక్యులేటర్ తెచ్చుకుంటా ఉన్నాను క్లాస్కి తొందరగా వస్తుంది ఎందుకంటే మనం చేసే మ్యాథమెటిక్స్ బాగా వీక్ కదా కదా ఊరికే ఎంఆర్సీ క్లాస్ వచ్చినా కానీ మనం చేసే మ్యాథ్స్ ప్లస్ మైనస్ కూడా తప్పు చేస్తాం సో వీ డిపెండ్ ఆన్ ఓన్లీ క్యాలిక్యులేటర్ So you will get n equal to 2 almost 1.99 or something is 2. Maybe you will get 1.98 or 99 approximately 2 you will get equivalent to. So it's a second order reaction, but the table is not showing it is a second order reaction. Though it may see, but they have not given the data values. In the previous problems, they have given the data values very clear to observe and see. But here they have masked it. They have not shown. But it is absolutely second order reaction. When you jump the concentration 2 times, your rates are jumping 4 times. They have not shown this. Clearly masked the data. Only some other data he has given. Maybe concentration of 0.25, 0.3, 0.35. If I get 0.5 concentration value, absolutely double the value, I may get the reaction rate 4 times. But that value he has masked it. But if you calculate, you'll get n equal to 2. Now if n equal to what is k?
76 into 10.
What is k? Minus 4. 7.6 into 10 power minus 4. 7.6 into 10 power minus 4. That will be k value minus r ar x4 to h. Rate expression for this component is equal to k into concentration of this ar x4 to h to the power 2. So this is the final rate expression. Is it okay? Any doubts in the problem? So the problem is second order only, but from the table of values we cannot conclude that because there is no doubling concentrations given in the data. Only data given, so we don't know. So we have formulated the same notation of the first principles. Take RA is equal to KCA power n. Do for the two data values, divide it, get the value. Clear? No. The following reaction was investigated. The following reaction was investigated as indicated in the following table. The reaction rate should contain concentration of component A as well as concentration of component B. The reaction rate should contain concentration of component A as well as concentration of component B. Determine the rate law. For this reaction, so the first data point is 1.2, 6.192. Second data point is 1.5, 1.2, 10.800. Third data point is 1.2, 3.1, 3.10, 17.856. Yeah. Any information from the table? Any information? Maybe doubling 4 times, doubling 9 times. Yeah. So that means we need to go by traditional way. But here he has given one line here. The reaction rate should contain concentration of component A and B. Definitely, when you write the rate expression, it will be there only. When you write what is the rate expression, if I write, is it given the reaction? Yes, he has given the reaction rate as 3A plus 2B. You write A3B2. This is the reaction he has given. So if I write rate minus RA is equal to K times concentration of A, concentration of B. I cannot write N for both because as he mentioning it contains concentration of A as well as concentration of B, and he want the order and he want the rate expression. So that means here for both I cannot write as N. Here the order may be different, here for order may be different. The order may be different. If it is elementary also, it is 3 here too. If it is elementary, it is third order, it is second order. With respect to A it is 3, with respect to B it is 2. So I don't know, I cannot keep for both as N here. It may be something N1, it may be something N2, we don't know. Okay, so we need to determine both N1 and N2 with the given data. And then we have to express what is the overall reaction rate and what is the overall reaction rate constant. So for example, if I write for, let us say for R1, if I write maybe minus R1, K times CA1 of N1, CB1 of N2. Maybe if I write for R2, K times CA2 of N1, CB2 of N2. See, if I divide it, probably what I said, this K will get cancelled. But here, the order is not same. Here different order, here different order. So what we have to clearly do is, which data should be used such that one will be cancelled and another will be calculated. So for example, if I take first and third one, these concentrations are same. So this will be cancelled, you will be left with only N2, so that you will calculate easily N2 value. So take this as R1, this as R2, this as CA1, fine, this as CB1, and this as CA2, and this as CB2. So that because these two are same, this will be get cancelled easily. And you will get N2 first. Do it. Similarly, to calculate N1, what I can do? If I take 1 and 2, this B will be get cancelled. Is it not? If I take 1 and 2 for the other set, B will be get cancelled, I will have to with only CS and N1 can be calculated. Do it. I want N1 and then N2.
N1 2.4. So N1 is 2.2.
N1 is
2.2.
2.2. Any other value for N1?
2.4.
Others. Others. N2. సరే N2 ఎంత వచ్చింది? N1 ఎంత? N2 ఎంత?
Sir, N1 1.1, sir. N2 వచ్చి 2.5. N2 1.1. N2 1.1, sir. N2 1.1. N2 1.1, sir. N2 2.5.
You will get N2 as
1.1.
N2 as 1.1 maybe approximately first order I can say. Approximately first order. What about N1?
2.2.
Maybe you will lead to 2.1 or 2.2 approximately second order you will end up with. Approximately 5. If I converge it, it is approximately second order. So my rate expression is minus RA is equal to K into CA power 2 CB power 1. Here A is A, here B. So because N1 is almost 2 and B is almost 1. Okay. Now what is my overall order? Overall order is addition of the individual orders. That means 2 plus 1. So approximately the overall order is 3. The overall order is addition of individual orders of the components. So 2 plus 1, 3. The rate expression is now what is K? Substitute here to get K. Any data you take, substitute values and get K value. No, that will be final rate expression we want.
3.5. 3.5.
So you will get minus RA is equal to
3.5.
maybe approximately 3.5 or 4 whatever it may be into CA power 2 into CB power 1. So this is the final rate expression. Clear? So with similar sort of problems, n number of problems can be given in the exam. Only thing is we should be very careful in looking at the data and calculation using the calculator, because our hand calculation memory we do lot of mistakes. Better we should rely on the calculator only. That's all, no? Because we do lot of mistakes. Fine? We don't know 2 by 4 is equal to 1 by 2. Ultimately we fight for 2 by 4 is equal to 1 by 2. Ultimately we lose. LHS not equal to RHS, we prove it. Fine? So have a calculator, look at the data, how the concentrations rates are varying, and proceed. Now let us come to the actuation energy concept which we have covered in the previous class. Okay. So I discussed the Arrhenius law in the previous class. So Arrhenius law talks about the temperature dependency of the reaction rate. If I take any chemical reaction, how my reaction rate is influenced by the temperature term. If I increase just temperature, what is my reaction rate? That is what Arrhenius has given in his Arrhenius law. He has expressed rate constant K as K0 into e power minus e by RT. This is what expression he has given. And I discussed this equation also. K is called rate constant, K0 is called collision factor, frequency factor, re-expansion factor, whatever it may be. And this is exponential term consisting of activation energy. We discussed what is activation energy. We discussed at a length. That is the minimum amount of energy required by the molecules to take part in the reaction. Fine. You may ask a question. Sir, you have given last time one example that if I leave a wood here without sparkling, it will not burn, will not combustion takes place. Fine. Here in this case, we can clearly see I am I am giving a flare or giving some activation energy. But there are so many reactions which are micro in nature. Here it is macro, you are seeing with visual eyes. But there are many chemical reactions in the nature which are micro. Micro means we cannot see by our eyes only. We have to rely on some microscopes, electron microscopes or optical microscopes. So where we don't know exactly is it the activation energy is taken or not. But we need to supply that activation energy, otherwise the reaction will not progress. So that is what activation energy we discussed. Now this expression, if I take maybe ln on both sides, ln k is equal to ln k naught plus ln of e power minus e by rt. Is it okay? So ln k by k naught is equal to minus e by rt. Is it okay? See, I applied ln here. Ln of mn is equal to ln m plus ln n. So ln k naught plus ln of this term. Ln of this term, because natural logarithm e get cancelled, so left with minus e by rt. This ln k naught I left to brought here. So minus ln k naught. Ln m minus ln n. Ln m by n. So ln k by k naught. Okay? Fine. So that means what? Maybe I can put it in another terms. For example, if I go with two temperature terms, because this is what we require finally, ln for the two temperatures. Two temperatures, if I write, maybe the expression, the first expression, maybe ln k1, first expression, because the constant is constant only, I will write by RT1. Maybe if I write for the second reaction at different temperature, I may write with 2. So if I subtract equation 1 minus equation 2, so this will be cancelled and I left with E by R into, okay, or in terms of, if I write ln R2 by R1, if I write ln K2 by K1 is equal to E by R into 1 by T1, because I am taking in reverse side, so 1 by T2. Maybe this expression we can use very in general. So the same expression ln k equal to ln k naught for at the temperature T1 I can write the expression like this. At temperature T2 I can write the expression like this. Subtract 1 from 2, so you will get ln k1 by k2. This will be get cancelled. So take E by R as a common. You will be left with 1 by T1 1 by T2. Because minus sign is there, I brought inside. Fine. Because rates, constants are proportional to the rates. Is it not? Because we rate always rate as proportional to k into constant. So rate is proportional to k. So k2 by k1, I write rate r2 by r1 proportional. So ln r2 by r1 is equal to ln k2 by k1 is equal to e by r into 1 by t1 minus 1 by t2. So this expression you can use for variety of problems. And what it tells is, if you have different temperatures, the reactions, if the problem is given with different rate constants, you can estimate the activation energy because you already know the inertial gas constant R. Okay, so from Arrhenius law, what we can estimate? We can estimate the activation energy E, provided if the data as given for the two temperatures where the reaction is carried out with the two reaction rate constants. Okay, so note down the problem so that we can solve one problem. The activation energy for the following reaction needs to be calculated. So the expression is CO plus NO2 gives rise CO2 plus NO needs to be calculated. The rate constants were found to be 0.028 ms minus at 327 degrees centigrade and 23 m power minus 1 s power minus 1 at 527 degrees centigrade. Given the rate constant value K1 is equal to 0.028. That is what K1. Here the K1 is given, K2 is given at two temperatures. Now he is asking the activation energy, which needs to be calculated. Very simple. You can plug in all the things. You can plug in, but when you are plugging, you make sure that the T is in kelvins. That means you should add here. So you should add 273 to get the value in kelvins. That means T1 you know, T2 you know, K1 you know, K2 you know. In this expression, you know R, get E. Do it. So what is the value of E R integrated? 8.314 joule per mole Kelvin. Okay. So take R value and solve it. Tell me. Given K1, given K2, given T1, given T2, asked to calculate only E. We know L and K2 by K1 is equal to E by R into 1 by T1 minus 1 by T2. That expression should be in the mind. Substitute, use calculator, bring the calculator from the next class. R value 8.314 joule per mole Kelvin. Sometimes R value changes with the units. Here all are in moles, joules, Kelvin. I have used R equal to 8.314. Otherwise, in atmosphere, what is R value? 0.0821 liters per place per mole Kelvin. అంతే కదా యూనిట్స్ మారిపోతే ఆర్ వాల్యూ మారిపోతుంది కదా ఫ్లూయిడ్ మెకానిక్స్ లో చేసి ఉంటాం మనం ఓకే సో ఇక్కడ జౌల్ మోల్ కెల్విన్ ఉంది కాబట్టి ఆర్ 8.314 తీసుకోవాలి యూనివర్సల్ గ్యాస్ కాన్స్టెంట్ ఎంతమ్మా తొక్కుతా 1339 దగ్గరికి వచ్చా ఇంకా ఏదో తప్పు ఉంది ఒక నిమిషం నాకు వాల్యూ చెప్పండి అమ్మా మనం ప్రొఫెషనల్ గా మాట్లాడుతున్నాం వాల్యూతో పాటు యూనిట్స్ కూడా చెప్పాలి కదా ఊరికే 1.3 అంటే ఏంటి అది మీటర్లా కిలోమీటర్లా జౌల్సా వాట్సా యూనిట్స్ తో పాటు చెప్పాలి మనకి జౌల్స్ పర్ మోల్ లో జౌల్స్ పర్ మోల్ ఆన్సర్ ఎంత చెప్పండి 1341 4123 2 3 జౌల్ per mole ఇంకొక అబ్బాయి ఇంకో ఆన్సర్ చెప్పాడు లాస్ట్ అబ్బాయి
Sir, 139259.
139259 జౌల్ per mole ఓకే
Sir, 133.9 kilojoule.
ఏది 13
133.9 kilojoule.
13 133.9
9 kilojoule.
this is the correct answer ఎవరు చెప్పింది కరెక్ట్ ఆన్సర్